Hello friends, welcome back to Matlab. Today we are going to learn about Simulink library browser and get familiarized with it. So there are many type of toolbox available in the Simulink library browser, but we need very few of them to make our projects. So at first I shall introduce you with Simulink Toolbox itself. In Simulink Toolbox you can see there is a tab named commonly used block. Under this tab you can see there are many type of tools available which we commonly use, like bus creator, bus selector, constant value vector, and delay function, multiplexers, relational operators, summation block, terminator block, scope, and many non-linearities block. Now under a continuous block there are many type of operations which we can do on signals, like derivative, integrator, PID controller, state space model, transfer function, and transport delays, etc. Now under a discontinuity block there are many non-linearity block available, like Coulomb, viscous friction, dead zone, quantizer, rate limiter, relay, etc. And under a discrete block there are many Z domain blocks available, like delay, different, discrete derivatives, discrete filter, FIR filter, unit delay, transfer function in Z domain, etc. Under logic and bit operations there are many type of logical operations which we can do with this toolbox, like AND operation, relational operation, interval test, comparison test, etc. Under math operations toolbox we can do many mathematical operations, like absolute value, addition of two signals, or find the product of two signal, increase the gain of some transfer functions, divide the signal, dot product of two signals, also summation, subtraction of signals, etc. Under sync tab there are many type of tools available for watching the output of any operation, like display. It displays the numeric value of any output signal. And there are two type of scope available here, or terminator block, or this scope plots the signal taking the x-axis as independent variable and y-axis as the signal axis, and this scope takes the time axis as independent variable and the y-axis as the signal axis. Under sources block you can see there are many kind of source available, like noise source, chipped signal source, clock, constant source, and sine wave source, step signal source, or you can generate your own kind of signal from this signal generator. So almost 70% of lab works in college are done under this Simulink toolbox. Next we will see the communication system toolbox. This toolbox is dedicated to communication engineering. Here we make radio frequency pair, multi-input output system, equalizer, etc. Next, the computer vision system toolbox. Computer vision system toolbox provides algorithms, functions, and apps for designing and simulating computer vision and video processing systems. We can perform feature detection, extraction and matching, object detection and tracking, motion estimation, and video processing. For 3D computer vision, the system toolbox supports camera calibration, stereo vision, and 3D reconstruction. Next, the Dsp System Toolbox. This toolbox is required for digital signal processing. In daily life, all signals are almost digital. To process these signals or to find its Fourier transform, we need this toolbox in Matlab. Next, the Fuzzy Logic Toolbox. Fuzzy logic is closely related to artificial intelligence. In digital system, we denote states as 0 or 1, that is either true or false. But in fuzzy logic, the states may be vary according to your implementation. It must lie from 0 to 1. Let us take an example of temperature of water from the tap. The temperature may be 70 degree, 50 degree, 30 degree or 0 degree. So these temperatures are denoted in the scales of 0 to 1 in fuzzy logic. Next, neural network toolbox. Neural network also relates to the artificial intelligence. It depicts the neural model like of our body. It is implemented with machine learning. Next, the Hdl Coder. From this toolbox, we can generate assembly language code which can be implemented with FPGA. Next, Simscape. It is a toolbox from which we can draw model of physical systems like hydraulic system, electric system, mechanical, thermal, magnetic systems, etc. We can also use a model as in another project. So from these discussions, we realize that what kind of toolbox are available in Matlab and how we can use it in our projects. In my next video, I shall show you how to make circuits and see its responses by simulation.